Good afternoon.
You guys beat me to it today. First time all year. I'm impressed. How's Opie today?
We're really good.
Is everybody there?
Yeah, they just went to go get lunch.
Okay, great. What are they bringing us today? Do you know?
Philly steak
Oh
sandwiches.
man, I love Philly cheesesteak.
Yeah, they're really good.
Probably better than the crap I had for lunch today. Okay. All right, well, good for you. All right, what's for lunch in Alchese?
I had a pizza for lunch.
Pizza?
Yeah. I don't know what these guys had. I had a salad.
Salad? I wish I would have had a salad. So is everybody there? Now what you say?
What is? Yeah, someone's just running a little late. I think she went to the bathroom.
Who?
Jada?
All right, so let me know if she doesn't come. Okay?
Okay.
All right, and Mogion, what's for lunch in Mogion?
Jada's right there.
Oh, Jada just came.
Oh, thank you. So what do we have for lunch in Mogion?
We got some fine Dairy Queen.
I had
Dairy
spaghetti.
Queen.
Yeah.
So I had one of those $5 box lunches for the first time in years because my daughter wanted to go. And man, I couldn't even hardly eat that. It was so full. I was so full. Of course, I upgraded to the Blizzard. So anyway, good stuff. So, but the school didn't have Dairy Queen. What did they have at the school?
No one.
You guys have a cafeteria?
Yeah,
Yeah,
but
but no
three
one
people
else
eat there.
Everyone just goes.
We all go home.
Yeah. You all go home.
Gross.
Yeah,
Man,
it's
gross.
just really bad.
No, that's too bad.
Yeah.
Well, so when I taught in South Carolina, there was a day like the cooks there made the best fried chicken you've ever had in your life. I mean, better than KFC, better than Church's, but whatever you think the best fried chicken is, when you're in the South and you have people that have cooked fried chicken all their life, I mean, anyway, so on days that they had fried chicken, I've never seen this anywhere else where I've taught, but members of the community would come in and eat lunch with the high school student. It was weird. I mean, you'd see like businessmen and lawyers and the mayor and all these people would come on fried chicken day. And it was crazy. All right, so is everybody there in Mogion?
No.
Who's gone?
Hannah Z and Hannah B are gone, and Timmy and Denon.
All right. Timmy, Denon, and Hannah B and Hannah Z?
Yeah.
Okay. All right. Okay, so today we want to start off going over that last little part of chapter of 9.3. So if you want to get those out, I'd asked you to classify the graphs for each equation. So we're going to do that, and then we're going to go on to 9.4. That's our plan for today. Okay. If I can wake this computer up. Okay. Come on. All right. All right. So let's start with. So does anyone have any questions before we get started here today?
What did you have for lunch?
It's funny because I was thinking I wanted something different, and I looked in the glove box of my car, and there was a ticket stub from when I went to the Joseph City Mogion basketball game. And on the back of the ticket stub, it had like a deal from Circle K. And I'm thinking, I've never eaten lunch at Circle K. Let's try it. and it's like so heavy in my stomach. I had those little like tornado things or something. Anyway, it tasted good, but after like 5 minutes, it's like, Anyway, it's nice and the people were nice, but I'm not sure I would recommend it for lunch. So anyway, okay, well let's go through. But that Philly cheesesteak, that still sounds good to me right now. So I think that's the best of all of us. So let's see that. So that's it, Hopi Philly cheesesteak. So next year, if you guys take calculus, we're actually trying to work it out so that as an instructor, I can go to the endpoints to the schools. See, what would be super cool is like if I could go visit each of your schools and then teach everybody else, and get to meet some of you in person. I would really like that, but the problem is logistics with, like, if I have a class back to back, or if it takes me, if I only have like 40 minutes between classes and the drive is an hour and a half. See, there's certain logistical things that will make it difficult, but they're up in the technology. So anyway, so what I'm saying is that maybe that's what I'm going to have to do next year is find out, when Hopi is serving Philly cheesesteak, and that will be my Hopi day or something like that. I don't know, but that would be super cool. So, and anyway, if any of you are juniors, maybe we'll figure that out for next year. Okay, so let's start with Alan. What is equation A? What's the conic section there?
Is it a hyperbola?
It is a hyperbola. Yes, ding, ding, ding. Good job. All right, let's try. Whoop. Alan again. How about B?
A circle?
B is a circle. Good job. And C. Wait, isn't everybody gone on this wheel? Except Emily. No, Hannah W's here. Okay. All right, Dwayne, how about C?
Hyperbola?
No. Okay, so can someone tell me why is it a parabola, not a hyperbola? Anybody?
Because there's no y squared. It's just
Yes.
x squared.
So if there's only one squared term, then it's a parabola. Okay? All right, and then the last one. Alan again.
An ellipse?
An ellipse is correct. Good job. All right. So, does anyone have any questions? We'll have Alan explain any questions that you have on this, because he owns this. Any questions on him? All right. Well, good job. Okay. Well, so that's it for 9-3. So I'm going to post this quiz either right after class or first thing tomorrow. All right, next. So now we're going to start in on 9-4. Okay. Now, by the way, 9-4 and 9-5 are very short sections. So we will definitely finish chapter 9 this week. Okay. And so we're in good shape because we just have one chapter to go, chapter 11. But you need to be getting caught up. If you're behind at all, make sure you get caught up because you're I'm going to be posting the Chapter 9 test probably Thursday or Friday. So just kind of be on the lookout for that. All right, so 9.4. 9.4 is on the rotation of conics. So up to this point, all of our conics have been like up, like a parabola going up, down, left, or right, or whatever. We haven't really considered what if they're at like an angle. So if they're rotated so many degrees, okay? And so what we're going to do is talk about like, okay, so if our original parabola has a point on it xy, then when we rotate it, it's going to have a new point x prime, y prime. And so we're going to talk about how to find those. So given xy, how do you find x prime and y prime? Or given x prime, y prime, how do you find the original xy point? Then we'll also talk about finding theta, and then a way to classify conics if there's a rotation involved, because it changes up the formulas a little bit. Okay, so first of all, what is it that causes a rotation? Well, when we talked about the general equation of all the conics, well, it's when you have this bxy term. So between the squared terms, bxy causes the rotation. All right. So if you add a bxy term to a conic section, it causes a rotation. So like an ellipse if it's an ellipse, then it will rotate the ellipse. So the ones that we just did at the end of 9.3, none of them had a bxy term. Okay, so just so you know. Okay, so these are the rotation relations. So given a rectangular coordinate system with axis x prime and y prime, rotated by an angle theta, respect to axes x and y, the two sets of coordinates x prime and y prime and xy are related by these four formulas. So the two in red are if you have the x prime and y prime and you want the original x and y, then x is equal to x prime cosine theta minus y prime sine theta, and y is equal to x prime sine theta plus y prime cosine theta. The blue ones are if you have the original points x, y, and you want the new points x prime, y prime, then they're related by x prime equals x cosine theta plus y sine theta, and y prime is negative x sine theta plus y cosine theta. So the x's and y's with the primes on them are the new coordinates after you rotate. Okay, so let's give you an example of how we're going to use this. All right, so let's say we have an original point xy. So x is -1, y is 5. And the angle is pi 6. We want to find the new point after we've rotated it. All right? So we're going to use the x prime equations. And y prime. So x prime is x cosine theta plus y sine theta. So we plug in -1 for x, and then pi 6 for the theta, and 5 for the y. Now, if we want the exact answer, then we can look up those values on the unit circle, or maybe we've got them memorized. The cosine of pi 6 is radical 3/2. the sine of pi 6 is 1/2. And so then we would get negative 3 over 2 plus 5 over 2, or negative 3 plus 5 over 2. And now, or we could, even from up here, we could just put it in the calculator. Now, when you put it in the calculator, again, you need to make sure that it's in the right mode. So whatever, if your angle is given in radians, then put it in radian mode. All right? Now, for the y prime, you look up that formula. So y prime is negative x sine theta plus y cosine theta. So again, we're going to put in negative 1 for x. So we have the negative of negative 1 sine pi 6 plus 5 cosine pi 6. Once again, if we want the exact answer, we look it up on the unit circle. So the sine of pi 6 is 1/2. The cosine of pi 6 is radical 3 over 2. So this gives us 1 plus 5 radical 3 over 2. Or we could, again, put this into the calculator right there from the beginning, and we get 4.830. So then our new point is the x prime, y prime. So both of those answers, so the 1.632 is the x prime, 4.830 is the y prime. So we started with this point negative 1,5, and then when we rotate it, then this becomes our new point, 1.634, 4.830. All right. So any questions on that? All right, so go ahead and try practice 1A on your sheet. And so you can do it exactly, or if you want to just do it in the calculator, that's fine. All right, so Jada, what do you have for x prime?
Is it 1.927?
All right. Let's see. Are you in radian mode?
No, I was.
All right. So key it in again and see if you don't get negative 2.464. Actually, if you just switch to radian mode and then press enter on the home screen, it should just redo it.
I got the same answer.
Okay. All right. Good. All right. Next, let's try the y prime. All right, Hannah W.
Negative 3.732.
Negative 3.732. Good job. So then this is your new point, your x prime comma y prime. Okay. All right. Any questions on that? Okay. Well, next we're going to talk about the angle. Okay, so if theta is the angle of rotation, then cotangent of 2 theta equals a minus c over b. That's the relationship. But don't write that down. Don't write that down. Okay? Now, the angle is, and the angle between 0 and 90, that's the answer that they want, that where it rotates. Okay? It's rotating the axis. Now, I always hated that they gave this formula. Okay? So I'm actually going to give you a new formula that's not in the book where I've solved it for theta. So here, what I do is say, well, if the cotangent of 2 theta is a minus c over b, then I'll just flip the fraction and say the tangent of 2 theta is b over a minus c. Because that's easier, because tangent's easier to, there's a tangent key. All right, so then 2 theta would be the inverse tangent of b over a minus c. And so then, and this is the formula I want you to write down, that theta prime, and that's, I'm putting the prime on it because it's actually the rotational angle, it's the reference angle, is the inverse tangent of b over a minus c divided by 2. So you do the inverse tangent, then you divide by 2. Okay, so this formula is not in the book. All right, so that's what I want you to write at the bottom of that first column, is this formula, because I think it's a little easier. Now, there are some tricky things about it, but we'll talk about that. All right. All right, we all got that? Okay, so let's give you an example here. All right, so let's suppose this is our equation, okay? So this term right here with the x and the y, this means that there's an angle of rotation, that there's a rotation because that term exists. So if that term isn't there, then there's no angle, okay? It doesn't get rotated. All right, so then what we do is the first step is to identify a, b, and c. So you say a is 1, that's the coefficient of x squared. B is the coefficient of xy, so that's 2 radical 3. C is the coefficient of y squared, so 3. These other ones you don't need. You don't even use them. Okay? So now you get the formula that I gave you, the inverse tangent of b over a minus c divided by 2. So first I do the inverse tangent. So the inverse tangent of 2 radical 3 divided by Well, 1 minus 3, A minus C. So either you do that in your head or you have to put parentheses around that. If you don't put parentheses around it, then it's just going to divide by 1 and then subtract 3. And that you don't want that. So here I put parentheses around it and I got negative 60. But then you divide by 2 and negative 60 divided by 2 is negative 30. So that's the reference angle, down 30. So the angle between 0 and 90, see, remember the reference angle is how far from the x-axis. So the actual angle is that we're going to have for our answer is going to be positive 30. Okay? All right? So go ahead and try practice 1B. Now, I don't care about the graph, so don't worry about the graph. All I'm asking you to do in practice 1B is to find the angle.
You can't divide it by 0, so I don't know what to do.
So then that means your tangent is undefined, right? So what angle between 0 and 90 has an undefined tangent?
Zero. Is it 90? Okay.
Yeah, because remember tangent is y over x. So at 90 degrees, that's 1 over 0 on the unit circle. And so you get an undefined tangent. So when you try this and you try using the formula, you're right, you do the inverse tangent of 2 over 0 or the inverse tangent of that's undefined. Well, so you have to know that. Your calculator isn't going to help you there. The unit circle might, but here, so you have to know that angle is going to be 90, and so then 90 divided by 2, so you still have to, so this is going to be 90, but you still have to divide by 2, and so your answer is going to be 45. Okay? Yeah, let's get rid of that. Okay. So, any questions on that? So the answer is 45 degrees. Okay? Because when you do the theta prime, that reference angle, if it's between 0 and 90, then that's your answer. That's your final answer. Okay? All right. Any questions? Okay. Now, all right. So I need you to think back to probably well, let's see. It's not really back to December. It's not the Taylor Swift song. So it's probably maybe October. All right. So does anyone remember the discriminant? What the discriminant is? Okay, well, let's see if I can help you. The discriminant, when we had, way back when we were studying the quadratic formula, the discriminant is the stuff underneath the radical. B squared minus 4AC. Okay, now here's another memory question. What did this discriminant tell us?
It helped you find the number and the types of solutions that you can get.
Yes, very good. You've restored my faith in humankind here. Thank you. Yeah, it turns out I learned this morning that actually my students don't always remember everything I've taught all year long. I was just stunned and kind of heartbroken about that. But thank you, Hannah. I appreciate that. I won't have to cry myself to sleep tonight. So the discriminant tells you in the quadratic formula the nature and number of solutions. Like if you have two complex solutions, two real solutions, one real solution, and it's all based on whatever number this is underneath the radical. Okay? Well, with these conics, these rotated conic sections, we also have the discriminant. So now what A, B, and C represent are different, but if we have this ax squared plus bxy plus cy squared plus the rest, okay, then the discriminant is still b squared minus 4ac. It's the same as with the quadratic formula. So when you calculate the b squared minus 4ac, if the discriminant is negative, you have an ellipse. If the discriminant is 0, you have a parabola. If the discriminant is positive, greater than 0, then you have a hyperbola. So this is slightly different than what we started class with, because the equations we started with class with didn't have the rotation. So there was no bxy term. So this is how to tell when your conic section has been rotated, just looking at the equation, what kind of conic section it is. So you calculate the discriminant. Now, can anyone tell me why is the circle not up there?
It can't be rotated because it's a circle.
Yeah, well, I mean, you can rotate it, but then it doesn't change anything. Okay? Beautiful. Thank you. Okay? Now I can actually be happy today because, yeah, when you rotate a circle, it doesn't change anything. All right? So, we don't have to worry about circles. All right, so when we are, so let's say we want to classify this conic section. All right, so the first step is to identify the A, B, and the C. So A is 13, B is 10, C is 13, okay? You don't need the rest of it. Doesn't affect it. All right, so then you calculate the discriminant. So B squared minus 4AC, so 10 squared minus 4 times 13 is negative 576. Since the discriminant is negative, then we have a what? What did you just write down?
Ellipse.
It's an ellipse. Okay? All right. So go ahead and see if you can do practice 2, please. Okay, Emily, what do you have?
hyperbola.
A hyperbola. That is correct. Good job. All right. Any questions on that? Does anyone have any questions on 9.4? Okay, so that's it. I told you that was a short section. Okay. Now, I think what we're going to do is we're going to finish early today. All right. So instead of starting the next section, because it's kind of short too, but I want to do it all in one day. So we're going to just call it. So on Thursday, we're going to do 9.5. We'll finish chapter 9. And so again, I'm going to post quizzes for 9.3 and 9.4 before then. So any questions? Oh, and then I think I told you we were having some problems with the videos. So as soon as the videos get uploaded, then I'll be posting those. All right. Any questions, comments, concerns before we call it? All right. Thanks, you guys, for working hard. Have a great day.
Bye.
See you
See you later.
Have a nice
See
day.
ya.
Bye.
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 Have a great lunch.